Hi students, so today I am going to discuss complex number. Okay, so why should we learn this complex number? At first we have to understand that things. So see, if we write x plus 1 equals to 0, that means we can find x equals to minus 1. Clear? But if I write x square plus 1 equals to 0, so we can write x square equals to minus 1. So we cannot evaluate the value of x here. So that's why we need to understand that complex number chapter. So at first I am telling you what is the definition of complex number. So we all know one thing, that in 2D this is x-axis and this is y-axis. Clear? But here we have to write, instead of y-axis, this is imaginary axis. Why imaginary? Because see, x square equals to minus 1. That means we can write x equals to root under minus 1. Clear? X equals to root under minus 1. So what is the meaning of that? This is the meaning of iota. So this is the basic definition of the imaginary function. Okay. So how we can write one complex number? See, if I write z equals to x plus iy, that means this x comma y, these two numbers belongs to real number set. Okay, so this is the basic things of complex number. So what is absolute value? Next topic is absolute value. Absolute value means you all know that if I am writing mod of minus 3, that means we will get 3. Clear? Otherwise, if we write mod of 3, that means also we will get plus 3. So this is the absolute value of real numbers. But now I am going to discuss absolute value of complex number. It is little bit different things. See, if I am telling you that z equals to x plus iy, so what is the modulus value or absolute value of this complex number? So absolute value is root under x square plus y square. How it came, I am explaining that things. Okay, at first we are drawing the 2D graph. Okay, now see, in this 2D graph we can say that here x and y belongs to real number set. That means x and y both are positive. That means these things lies in this point, x comma y. Clear? Okay. So what is x? Suppose we draw one line, that means these things is x. Clear? And these things is y. Clear? Now we join origin to these points. Okay, origin to this point. That means it forms a right angle triangle. So in right angle triangle, we know that here Pythagoras theorem is applied. That means applicable here. So if we apply that Pythagoras theorem, that means we can find this hypotenuse. So hypotenuse length will be root under base square plus perpendicular square. So this is the actual meaning of absolute value. Okay. Now I am going to discuss about algebraic operation. Okay. So algebraic operation. So at first you see I am giving you one example like that 2 plus 3y. Okay. This is one complex number, right? So I am taking another complex number z2 equals to 3 plus 5y. So if we add these two numbers, that means z1 plus z2, then we will get 2 plus 3i into 3 plus 5i. So here also plus sign. So now we have to add this part, that means 2 plus 3, and after that we add the coefficient of I. Okay, that means it will come 5 plus 8. This is the addition rule. Okay, now I am going to discuss subtract things. z1 minus z2. That means we can write 2 plus 3i minus 3 plus 5i. So if we subtract, then we will get 2 minus 3. That means we will get minus 1 plus I into C. Coefficient of I is 3 and here is minus 5. So 3 minus 5 minus 2. So your result will come minus 1 minus 2i. Okay, now I am doing the product. So see z1 into z2. So here we can write 2 plus 3i into 3 plus 5. Okay, how we can do? See, just we multiply 2 into 3, that means 6, plus 2 into 5i, that means 10i, plus 3i into 3, that means 9i, and 3i into 5i, that means 15i square. So 15i square. So here we have to learn one more thing. I will discuss the power of iota, but here you can see that few times ago I have written iota equals to root under minus 1. That means I square equals to, we can write minus 1. Clear? So here we will put minus 1. So we will get 6 plus 10 plus 9, that means 19i minus 15, because we put here I square equals to minus 1. So we will get minus 9 plus 19i. Okay, see this. If you want, then you can take one screenshot. Okay, now I will discuss one more operation, that is division. See, z1 divided by z2, that means we can write 2 plus 3i divided by 3 plus 5y. So here 3 plus 5y, so its conjugate is 3 minus 5y. Suppose I am writing one complex number like that, 3 plus 5y. So its conjugate means z bar, it is denoted by conjugate of z, equals to 3 minus 5y. So here we multiply by its conjugate, numerator and denominator. So 3 minus 5i divided by 3 minus 5i. Clear? So now see that the denominator part is a plus b into a minus b. So we can apply a square minus b square. So 3 square minus 5i, that square. And now we multiply the numerator things. So 2 into 3, 6. Plus 2 into minus 5i, that means 10i. Plus 3i into 3, that means plus 9i. And next thing, 3i minus 5i, that means 15i square. Okay, now see. 6 minus 15 into I square means minus 1. So I am writing minus 1. This minus 10i plus 9i, that means minus I. Clear? And denominator part is 9. 3 square means 9 minus 25i square. So minus 25i means I square means minus 1. So if we calculate these things, that means we will get here minus 15 minus 1. If we multiply, then we will get plus 15. So plus 15 plus 6, that means 21 minus I. Divided by denominator part is 9 plus 25. So it will come 34. So this is the divisibility rule. Okay, for complex number. Just see it. Okay, now at first I am telling you the properties. After that I will tell you power of iota. So properties is like that. First one, commutative property. Commutative property. So this property is holds for only for addition and multiplication. What is the property? No, the property is a plus b. You can write here z. Okay, so z1 plus z2 equals to z2 plus z1. And one more thing, z1 dot z2 equals to, we can write z2 dot z1. Okay, so here commutative property holds only for addition and multiplication, and same thing here also hold the for addition and multiplication. Here also hold associative and distributive law or property. What is associative or distributive law? Now suppose there is three numbers. So z1 plus z2 first bracket plus z3 equals to z1 plus z2 plus z3. Okay, this is associative. What is distributive law? Distributive law means if z1 into z2 plus z3, that means z1 z2 plus z1 z3. So here you can check these formulas. How? Now you just choose z1 equals to one complex number, z2 equals to another complex number, and z3 equals to another complex number. You just put here, then left hand side and right hand side must be equal for addition and multiplication. Okay. Okay, now I am going to discuss about power of iota. So power of iota means we all know that I equals to root under minus 1. So if we square it, that means I square, that means we will get minus 1. Clear? Okay. So if you multiply I square into I, that means we will get minus 1 into I. That means minus I. Clear? Now if we multiply it, I to the power 4, this is the value of I cube. I cube equals to minus I. That means I to the power 4 equals to, we can write I square into I square. That means minus 1 into minus 1. So we will get plus 1. Suppose if we multiply, suppose we have to find I to the power 5 value. That means we can write I to the power 4 into I. So what is the value of I to the power 4? That is 1. So 1 into I, that means I will come. So this is the basic concept of power of iota. Just see it. Now see the next topic, that is Argant Plane. So now I am going to discuss about Argant Plane. So what is Argant Plane? You all know x means, x-axis means abscissa and y-axis means ordinate. Okay, so see here I draw one axis. Okay, suppose here one point is x comma y. Okay, x comma y means z equals to x plus iy. Clear? So its conjugate z bar equals to x minus iy. So here we plot one more point, that is x minus y. Okay, so x comma y and x comma minus y, this is the image point of x comma y. No, x minus x comma y minus y, x comma minus y is the image point of x comma y. In the real line it is called the argument. Okay, so the see why it is very much important, this argument. See, if I am drawing one more xy axis. Okay, why it is important? Now I am telling you. Okay, why it is important. Okay, at first I will tell polar coordinate. After that I will link up these two things. Okay, see, z equals to x plus iy. Okay, so x equals to, we know, put x equals to r cos theta, y equals to r sin theta. So that means we can write here r common cos theta plus I sin theta. Clear? Cos theta plus I sin theta. So here theta, only for theta we need this Argant plane. Why? See, if here sin theta and cos theta both are positive, sin theta, cos theta, both suppose positive, that means this argument is theta. Okay, here in this coordinate only sin theta is positive, and here sin theta and cos theta both are negative, and here only cos theta positive. See, okay, so I am telling here theta. Okay, now this quadrant we can write here pi minus theta. Okay, and this quadrant we can write minus pi plus theta, and here minus theta. So what is theta actually? Theta means the angle. Okay. So suppose this is polar coordinate. That's why I am telling about that theta, cos theta, sin theta, this angle. But suppose it is in Cartesian plane, that means we have to write theta equals to tan inverse y by x. That means how we can solve? No, solve at first. See, at first we have to see about the x plus iy. That means x and y both are positive or not. You can see, you can solve this type of problem in Cartesian method also and polar coordinate method also. So at first you have to see that x and y, these 2 points lies in which quadrant. Okay, so in which quadrant you see that, suppose this is positive and this is negative. That means x positive, y negative. That means this quadrant. So this quadrant means you find the theta's value. Okay. So what? Suppose you have in question they are asking that what is the argument of this function. You have to write, at first you find the theta, then you have to write minus theta. Suppose theta's value is pi by 3, so you have to write that minus pi by 3 is the argument. Why? Now because this point lies in 4th quadrant. Okay, so if next part 2 we will solve the example. Okay, that time you will clear all the concept, because here I am just telling you the concept of this chapter. Okay, so you just write down these things only. Why I am writing sin theta cos theta positive, sin theta positive? Because in trigonometry first chapter you know that first quadrant all positive, okay, and second quadrant only sin positive, here tan positive and here cos positive. Only that concept I have used here. Okay, now in part 2 I will give some problems. Okay, I will discuss here some problems. That time definitely you can understand whatever you have doubt now. Okay, next is Euler's formula. So what is Euler's formula? Suppose e to the power I theta equals to cos theta plus I sin theta. Okay, this is the Euler's formula. Cos theta plus I sin theta. Now I am going to tell you what is Euler's identity. So if we put theta equals to pi, that means we will get e to the power I pi. That means cos pi plus I sin pi.